All right, guys, welcome to this page of the notes. Again, what we're doing is we're working on hyperbola, and now we're going to go ahead and take a look at some of the example problems, things that I might ask you to do if you're taking this class with me on homeworks, quizzes, tests, things like that. And what we start off with is I give you some information about the hyperbola, and I ask you to write the equation. Now, we've seen these before with the parabolas, the circles, and the ellipses. This isn't going to be any different. Plot the information that you've been given, see if you can figure out the orientation of the hyperbola, and then go from there. Just pull the appropriate information off the formula sheet. You'll be off and running. Here we go. The vertices. Well, I have a vertice at negative 4, 0, and 4, 0. So 1, 2, 3, there's a vertice, and 1, 2, 3, 4, there is a vertice. I have a foci. All right, fantastic. At minus 5, 0, so that's going to be right there and right there. That is a focus. That is a focus. This is a vertice and a vertice. And so my transverse axis always has the foci and the vertices on it. So because my transverse axis is horizontal, I'm going to need to use the equation or the formula for a horizontal hyperbola, and check it out, it's centered at the origin. My center is right there. So I have a couple of things here. I know that I am centered at the origin, centered at 0, 0, and I know that I am horizontal. All right, so what we're going to do is go ahead and pull the appropriate equation off of the formula sheet, find the one that's centered at the origin, find the horizontal, and you get this one. It is x squared over a squared minus y squared over b squared is equal to 1. In order to write the equation, I need the value of a and the value of b. But what did they give me? Well, remember, the vertices are a. The distance from the center to the vertice is a. So I know that a is this distance, just like it was with ellipses, that distance. So a is equal to 4. The value of c is the distance from the center to the foci, which in this case, remember with ellipses, the foci were always inside the ellipse. Now with hyperbola, right, the parabolas have to wrap around the foci. So that's why now the foci is outside of the vertice, right? Because that parabola is going to wrap around that foci. So the distance from the center to the foci is c, and in this case that is 5. So I know that a is equal to 4, c is equal to 5, and I got that handy dandy little Pythagorean theorem right there on the formula sheet that tells you that c is equal to a squared plus b squared. Let me take the square root of all of that. Well, here we go. C is 5 equal to, I need a 4 squared plus b squared. I have to square both sides, so that's going to give me 25 is equal to 16 plus b squared. Let me slide up a little bit. Let's see here. Subtract 16 from the other side. I wind up with b squared. 25 minus 16 is going to be 9. Take the square root of that. I get b is equal to 3. b is equal to 3. Okay, now remember, b is the co-vertice. So that means I would go up 3 and down 3. 1, 2, 3. There. Down 3. 1, 2, 3. Right there. Okay, now I will write the equation for my hyperbola in just a second, but I want you guys to see how easy it is to graph these things. Remember, what we're going to do is we're going to put in those guidelines. The guidelines will allow you to draw the hyperbola, and you start with the rectangle. Remember, the rectangle must go through the vertices and through the co-vertices. So go ahead and sketch in that little rectangle that goes through the vertices and the co-vertices. It's going to be this guy right here. Again, I'll do it as the dotted line because these are simply guidelines. They are not actually part of my graph. It's just what I'm going to use to help me get my graph. So there we go. There's that rectangle. Now remember, the asymptotes, all right, the slanted asymptotes run through the rectangle from corner to corner, corner to corner. So we're going to run an asymptote right up through here. Make sure you extend that asymptote all the way through the coordinate plane. Go in the other direction, right down through that corner there. Going up through this corner over here. Going down through this corner, right over here. Awesome, perfect. Okay, so now in blue, right? Remember, the hyperbola must go through the vertice, wraps around the focus, and cannot touch the asymptotes. So I got to go through that point. I cannot touch the asymptotes, and I have to go around the focus. Well, that means it's got to look like this. And it is just that easy to graph a hyperbola. Guys, it's a sketch. That is good enough for me. Once you find the vertices and the co-vertices, put that box in there. Get your asymptotes going through the box from corner to corner. Make sure your hyperbola goes through the vertices. Don't touch the asymptotes. Well, if you touch it, I won't freak out. Just do not cross the asymptotes. And you got to wrap around the foci. Now let's go ahead and write our equation, because that's what I asked you to do. Okay, so my equation is going to be x squared over a squared. A is 4, so that means a squared is 16. So I'm going to have x squared over 16 minus y squared. B squared was 9 over 9, and it's all equal to 1. And there we go. All right, so that's how hyperbola are going to work, both graphing it and finding an equation for it based on me giving you some information. Head on over to the next page of the notes. We'll try another one of these. I'll meet you guys there.